Welcome everybody. This is our weekly lifecycle management provisioning technical work group weekly meeting. I didn't prepare any agenda and I'm not feeling too great today. So I wanted just to have a quick chat about where this work group is going and why we're not seeing a lot of participation, like active contribution. And there is one pull request I wanted to point to the group to start reviewing. And that's it. If people want to add more to the agenda, feel free. I'll pause to give people a chance to speak up what they want to talk about today.
Yeah, hi Boris. I missed last week's meeting, but I listened to the recording, and I came away with a couple questions around the inventory protobuffs. So we have time. I'd like to discuss that for a few minutes.
Absolutely.
Hey Boris, this is Mati from Intel. I will have one question related to the diagram on the provisioning. Basically about the redfish proxy. Maybe it was already explained what exactly is the role of it and how it works, etc. Maybe in the previous meeting. So if that can be taken offline, so I just view some previous meeting, that's all right. But
No,
I could use some background.
Yeah, this is excellent. Let's do it. I really like that people suggesting new topics. I'm kind of tired of talking by myself. So thanks, team and Marseille.
Okay.
Let's give other folks also the chance to add something before we jump into team's question. More questions, like even generic questions, weekly meetings, monthly meetings, direction we're taking, like any generic things that you're interested what this work group is doing. I'm all open to have very honest conversation.
I might have more once I understand the redfish proxy. Maybe I'm going to go around, steer things up a bit, maybe challenge some things. I don't know. Let's see.
I like challenge. I accept it. Cool. Okay. So let me quickly show you the pull request and then we jump into team question. So, okay, I'm sharing, right? So Ted took an attempt on the boot sequencing page that we did and created this pull request. Has quite a bit of changes. So I just want again to bring to this group attention for some people who are not actually actively pulling and monitoring the GitHub itself. So there is a bunch of changes here for the boot sequencing. I think this is Ted's attempt to actually solve and standardize how the boot sequencing works. Addresses all the issues for the simultaneously boot up and the reboot and the crashing scenarios. So just expanding on my initial page with his proposals and ideas. I think if you're interested in this kind of work, this is expected from you to go into this pull request, add a bunch of comments, add your review. So please do. I won't be merging this until I see at least 2, 3, 4 comments from different people. Make sense?
Yes.
Okay.
Yeah, I hadn't seen all those changes. I'll have to go look at those.
Yeah, it's just from today. So this is
there's sort of a hornet's nest of nasty problems in that area. So.
I agree.
There is. And that's why I think we need to bring them out. Because I think there's, go ahead.
Traditionally, those problems have been solved in embedded systems with sort of having a priori knowledge about what the system can do. And we don't have that benefit, so it's much more difficult.
There are implications on the operating systems, and neither of the key operating systems we're looking at today do particularly well in this regard.
And just so everybody has the background, Ted has extensive experience with Dell and DPU vendors implementing Project Monterey with VMware, which we announced publicly and it's available already. I think we're shipping. So this includes a lot of lessons learned from that experience, how VMware, DPU vendors, and Dell collectively try to solve the same issues of boot sequencing, rebooting, and all that stuff.
And frankly, that was an easier problem to solve because we were dealing with the same OS vendor on both the DPU and the host.
Agree. Just to give the background
Yeah.
of where you're coming from, and this is not theoretical, but actually from experience in production. Okay, I'm ready to move on to team questions on inventory, unless people want to ask more questions about this. I prefer you kind of read through it offline, post comments, and then next week we can pick up and have an honest discussion on this pull request. Make sense?
Yep, sounds good.
Okay, moving to the inventory. I can open 2 pages, I think, for the inventory. One is the main page, and then the protobuf, and then the implementation for SMBIOS bridge. Makes sense.
Yeah, it's the protobuf. That's what I want to speak to.
Yeah, sure. Just a remind, for local inventory, SMBIOS DMI tables, this is what we're doing. And today we were talking about remote network inventory. Redfish is pretty standard, and gRPC we defined proto definitions here, and I implemented the example implementation here. So go ahead, Tim. This is a protobuf API.
Yeah, so if you look at these areas in the protobuf, BIOS, system information, chassis information, baseboard, and then there's a base, So I get a little confused when I'm starting to, and device, there's a device one down there too. With these names are a little vague in my mind. I mean, so if I'm remote and I'm getting this information and the DPU reports to me, hey, it's system information, what does it mean by system information? And how is that different than chassis information or baseboard information?
Absolutely good question. I can explain how I came up with this protobuf APIs. And again, this is a draft, so everything is and can be changed. What I did is I took SMBIOS spec, and I took DMI decode Linux utility who parses the DMI tables according to SMBIOS spec from DMTF. And those are the types that are defined in SMBIOS spec. So we have BIOS type, system info, chassis info, board info, CPU info, memory info, and others. If you look into this page, for example, we can see the DMI decode type system, for example, returns this kind of information. So I encoded all of these fields just in protobuf. So this protobuf and this repository is supposed to be one-to-one mapping of the DMI decode, which is SMBIOS DMI tables specification. So
Okay, so this example you're showing here is for a Dell server, a PowerEdge R750.
Yeah, this is example for Bluefield.
Okay.
And this is example for Marvell. Yeah. Just wanted to show fields that are actually populated because NVIDIA, in this example for the card that I have, don't populate serial number, for example.
Would OPI give any guidance to a DPU vendor on how to fill out these different parts of
Absolutely. And this is
it can be confusing. So
yeah, so Lee Ballard, I'm not sure, Lee here, yeah. Lee Ballard from Dell, he took an initiative to go through the spec itself of SMBIOS DMI, look into all the tables, and the tables are corresponding to this. So we're basically talking about BIOS table, system table, chassis table, baseboard, CPU, memory, and maybe others. In each table, we have fields like here, for example, right? So we have the manufacturer, the product name, version, serial number, UID, SKU number, family, basic. This is example for the system, right? So go through this table, identify which are mandated by OPI, okay? And actually work with vendors and push vendors to implement
Yeah, and sort of give them some guidance on what we
what
mean
and
when we
how
say,
to deploy.
what do we mean when we say system? What do we mean when we say baseboard?
Absolutely.
What do we mean when we say chassis?
Alok, I see your hand. Just a few more sentences. I'll give you the chance to comment. So, so this is the local DMI decode with SMBIOS, and my chance on the protobuf is just copy paste exactly and replicate exactly the same behavior over gRPC. We did want to put a single gRPC request to get all these tables in a single request. This is why you see all the messages defined, and then we have the response message, which combines all the previous messages. You can see here that some fields are missing because this is a first version draft. I want other people to come in and add more fields, either from Lee Ballard work on standardizing things, or vendors coming in and say our customers need this and that field in addition to what you identify. So all the contributions here to this protobufs are very welcome. You can also see here lack of actual typing. I return everything as string, while for dates and versions we can actually return the protobuf proper types. This is all, again, because this is a draft version, and I want other folks to join and participate in this protobuf definition work and try to solve all of the shortcomings of this definition. Alok, ask a question, and then we can go through the implementation itself.
Yeah, thanks, Boris. I think I second the thought which Tim was mentioning about having the introduction about the corresponding tables. Plus, maybe it would be good to have like what all tables would be mandatory versus the optional one. For example, I see the chases information. I think that might not be applicable for the IPU DPUs, considering they will be deployed on a system, and that has a chases number, not the DPU IPU, right?
So a couple of comments. First of all, as I mentioned, Lee Ballard is a volunteer to lead the discussion on what tables and fields are mandatory versus optional. So we need to have and possibly have an update from Lee on this work stream. This is one. Second of all, the proper protobuf definition require us to document here each and every service, each and every RPC, each and every message, and each and every field in the message. Once we do that, the way I structured all our protobuf definitions, we have automatically generated documentation, which is AutoGen MD. So once we have that, all the description and labeling will be filled here in the information. And you see some of it already filled, like object ID and the UUID and different scholar types, all of that is implemented. So once we just finish the definition and add all the necessary documentation, this auto-generated markdown page will be our documentation to all the inventory APIs. Does it make sense?
Yep, makes sense. Thank you.
And the last comment on the chassis, think about JBOFs. JBOF is a bunch of the chassis with a bunch of drives, which DPU acts as a single processor inside that exposes the local chassis drives to the network, either TCP or DMA. This is my definition for the JBOF, for example. In that case, maybe, I'm not saying must, but maybe the chassis information can be useful. This is why I put it here, but this is all open to discussion. If somebody feels and we can vote that chassis information is not useful, just remove it from here. This is all code based.
Yeah, I mean, I'm not sure either, like with whether it has to be like you said, could be useful or maybe not, but maybe in the first versions we can mark some of them as optional and decide upon in the later releases. Like
absolutely. And protobuf have internal documentation of each field in the optional or mandatory. So again, I'm really looking for people to pick this up, add missing fields, change the data types, mark optional versus mandatory inside this protobuf definition, propose a pull request. we can all review it and merge it. This is something that I cannot do alone. But again, once we add the missing documentation, as I said, this Markdown page is automatically generated all the time, and we will see all the description both on the messages and on the field. So I hope that also team question on clarifying what it actually means can be really helpful once we have that.
Yeah, I mean, the danger is to have different vendors interpret ambiguous things differently, and then we end up with a disjoint set of reporting.
Absolutely.
Yeah, so I do know the embedded use cases like the JBOD, right, are going to stretch our APIs, right, to the breaking point. But if we come back to more the conventional, hey, I'm a card plugged into a server. When you say baseboard, what does that refer to in that context, that topology?
Lee, if you hear, you read
Yeah,
the
I was gonna go look at the DM. I'm hoping that this is defined in that DMTFS and biospec of what
Okay,
these.
so we're not clear. None of us are clear yet what that means.
No.
And is there
I
an
know-
intention
I know
by
that-
anybody? Is there an
know that-
intention by anybody to report when you do an inventory on an installed DPU to report anything about the system it's installed in? Like what slot is it in and what kind of server am I in? And
So that's really hard to determine from the DPU usually.
yeah, it would have to be doing inventory requests to its host, right?
Well, it actually have to be pushed from the host to it because there's
Yeah.
not a lot of ability for a DPU to pull information from a host as a PCIe device.
But if you imagine, you know, I'm a server and I have 4 DPU cards installed. For somebody doing remote inventory, it would be useful to be able to differentiate those 4.
Yeah, I
Absolutely.
think it may have been somebody from RHEL or Red Hat or something. Yeah, so there's been different kind of methods to do that. You know, whether you
Yeah,
but
Red
it
Hat
usually
mentioned-
means an external entity figures that out by getting the inventory and saying, okay, these PCIe slots have these serial numbers, these DPUs have these serial numbers, therefore there, and you know.
the same, yeah, in the same.
Yeah.
spot. This is, yeah, you're correct, Lee. This is from Red Hat looking into VPD information exposed over PCI Express into the host,
I
and they
mean,
matching it to the serial number of
yeah,
each.
okay. Because one way you could enable that is if you were to expose over the remote inventory query what your PCIe device ID is, and maybe even what your base address is. So that when you scan multiple cards, you'd be able to see, that these have different device IDs on the PCI bus. But you're thinking more of a serial number based approach is a way to go, that those serial numbers are visible to the host and it's reporting them, and then we're correlating that to the inventory queries we're getting off the individual cards.
I don't know the answer. I think that what I explained is how Red Hat approached this today without having OPI. And I think we have an opportunity to improve that.
Okay, and I think what I'm suggesting here is probably beyond your first pass. It's a second pass problem.
I agree. Okay.
Yeah, we probably just need to, we'll start with the minimal set and then see what other things are needed for other use cases.
But another quick comment is regarding to the previous mandatory versus optional fields and the documentation and interpretation of different fields. We created this repository SMBIOS validation tool. This tool supposed to run on DPUs and check compliance with OPI. So this was forked from Google, how they do the SMBIOS validation. So this tool actually parses the DMIDI code information and validates all the different types and handles and all the different fields. So this tool is, I think, is very important in OPI in order to check compliance of different DPU vendors to OPI in this local inventory DMI SMBIOS new world. So we can run this and we can immediately see the different exceptions, like the version is not in the correct format, the release date is not in the correct format, or missing field, extra fields, missing tables and stuff like that. So this will help us to check compliance to OPI.
So I had a question with this. Do we want to try and lighten it a bit okay. So do we want to require that Python 3 be installed on all the DPUs and such, or do we want to try and do some kind of remote execution where this tool runs somewhere else and then you SSH onto a DPU?
I wouldn't complicate it. I would assume Python 3 is installed on all the DPUs and we can run it locally. Whether it's true for production or only for the validation stage, I think it's a safe assumption. We can always wrap it in Docker as well. So the Python 3 Docker is available very widely for ARM. So I'm not seeing any problem of continuing with this assumption that this tool runs locally on the DPU, assuming Python is installed.
Okay.
This is my view. The last comment on the same topic is I didn't want these protobuf APIs to be purely theoretical. So I went ahead and implement the actual implementation for those protobuf APIs. Because I said those protobuf APIs are correlate one-to-one for DMI decode. So this is exactly how the code looks like. I created a new repository, OPI to SMBIOS bridge. Basically, I implemented inventory Go. I use a standard library that Red Hat recommended for me in Go to access all the DMI decode information. I don't know why this is extremely low. So this is a standard library that Red Hat using and everybody else recommends also to use to get the DMI decode table parsed. So basically, I implemented the single inventory get gRPC. I use that library to get all the information from CPU, memory, chassis, BIOS, baseboard, and product. As you can see, same naming in the library, same naming in protobuf, same naming in the spec itself. So this is very easy to match. And then I just return a single response with all this information filled. So this actually really helped me. This is an example response, how it looks like on Mellanox NVIDIA card. And I got a Slack channel today, I think, showing how it looks like on Marvell card as well. I can definitely add it here to this page. But this is how it looks like today on the card that I have in my lab. So this is running on actual physical cards here. Any question on the code itself?
Yeah,
really
but it's not
Go
sure
ahead.
why the processor is not showing anything in for NVIDIA and for Marvell. We'll look into it.
Yeah, sure. Thanks. I really want to emphasize this code thing, right? OPI is an open source project, is not a standard only project, right? We need to produce code and we need to work on code. I see absolutely zero contribution from this group on the code itself. So this is the next topic that I wanted to bring to this group is why you think that people from this group are not contributing any code to the project and only contributing some very limited amount of markdown pages and discussions online during these calls. If we are not going to do code, there is no point of having the open source code-based project. I created this code, I created testing, I created code coverage, CI/CD pipelines for all our repos. So we all code driven. You can actually run this Docker, as I show here, on NVIDIA and Marvell recently. Thank you for Marvell team to running and showing the output. So I think this is extremely useful and maybe I'm missing something. So I want really to have the open discussion from the group. What am I missing? Why people are not writing code?
I mean, for me, it's been a little bit of access to hardware since a lot of all our hardware resources have been tied up. in development right now, or validation. But I should be getting some access to cars.
Marvel, I expect you to write a bunch of code here, right? So far you validated a bunch of stuff, but not a lot of contributions back. So really interested to hear what's happening. Same from Intel perspective as well.
Yeah, we are
Just
trying
j-
to get our firmware teams engaged, and it's been a bit of a challenge. I hear you loud and clear. And that's something that we'll plan to address.
Thanks, Person.
just joined today, so I'm sniffing around.
Thanks. Okay, I don't want to drag it. I want to bring this to the group attention that people are expected to contribute. And if this is not happening, I will definitely step down. I'm not interested in running this subgroup if we are not doing any code. So if somebody wants to replace me in the leading position of this technical working group, feel free to reach out. We can work out the details. Unless we're going to see some contribution going forward. Okay, didn't plan to drag it or bring anybody down. We had last item on the agenda from Intel. Maciej, go ahead and bring your item. Let's discuss.
Yeah, sure. Let me pick it up. So there is this picture in the provisioning. I'm assuming it's not only provisioning, it's more of the deployment design. Where is it? Here. Kick it off. All right. Can you see my screen?
Yes.
All right. So basically, I'm trying to figure out, the what kind of deployments the OPI is trying to, figure out. I know roughly, roughly. I know Monterey deployments definitely, or at least, what's the design, like which entity within, whether it's the NIC BMC or DPU, IPUs host, and the roles of those entities and the related flows. But I'm going through them and working on the project for a bit. I'm kind of interested in the element here, the Redfish proxy.
Mm-hmm.
Considering what is the hierarchy of the Redfish servers, or the external entity that's managing either host or the IPU or both, if the hierarchy of the BMC and the NIC BMC is either the NIC BMC is on top or the platform BMC is on top. I've seen ideas of both already, so I'm trying to figure out what was the reasoning of or the rationale for having the Redfish proxy here, and what kind of role it's supposed to have.
Yeah, good question. So let's clarify.
Mhm.
Those pictures are showing different potential DPU hardware components. Okay, we're talking about different deployments models, whether you have platform BMC or don't have platform BMC, full versus small. We have, I think, even JBOF I added to the picture, which doesn't have a server at all. So those pictures are showing different potential deployments. The only deployment that OPI is focusing on and validating and recommending and providing is secure zero-touch provisioning. Secure zero-touch provisioning, the BMCs are not participating in that process. All the other provisioning methods that we use today, for example, through Redfish and other methods are possible, but outside of scope of OPI provisioning, of OPI today. If we want to change it, I'm okay with that.
Okay, Boris, just
Sure.
to stop you for a moment. It's not only about provisioning. In terms of the overall, the ecosystem or the life cycle of the overall platform, including the IPU or DPU. The Redfish server is not only the provisioning element, it's also configuration element, right?
Not always. For Intel, for sure. But for example, if you take AMD card or AMD Paisando card, they only provision, configure, monitor, all the lifecycle management operation, all the operation that you can think of, they all doing over gRPC protobuf-based API. There is no redfish.
Yeah, okay, gRPC, but it's terminated at the DPU IPU, or it's in the BMC.
For MD Pensando, there is no NIC BMC.
Right. Okay.
So, for example, we need to accommodate those guys. That's why we are not. We're showing the second picture that you are not showing here on this, which is not having the BMC.
Let me pull it.
You can zoom out. Yeah.
No.
This is showing the picture.
Yeah, I'm isolating those.
Yeah. Okay.
Sorry, I have too much stuff open here. Got a filter. Okay, this is
This page basically
in
the chat.
It's this one, right?
Yes, for example.
Mhm.
In this case, you still have your server with your platform BMC, but the DPU doesn't have any BMC. So you either have an option to run some kind of redfish server on your ARM core, main ARM cores, or like in AMD Pensando, you're just running gRPC services for everything, including the lifecycle management and
Okay. Is the gRPC that you're talking about? Is it a part of the DPU IPU, and it's managed like it would be completely separate, or is it going into BMC of the platform? Is the platform involved in the lifecycle management of the Pensando card, for example?
Oh, okay. So you are touching very good questions, which are not part of this page. We're just taking a very iterative and compartmentalized approach. So bear with me.
Yeah, I haven't seen any diagrams in the management, so unless I'm
Yeah, you're right. Management, the lifecycle page is just something that we just started to work on. This is why you don't see anything.
Okay.
Yeah. But basically, how you would do the upgrade of the DPU, this is a question that we need to answer next. And this is why Stephen helped us creating this initial page for the lifecycle markdown page. We are very welcoming all the different approaches and information. As I saw two approaches. I saw that platform BMC is driving everything. Obviously, this is Dell approach. Or Dell preferred approach. We saw Intel approach when for some customers, you want to be the center of the data center and drive everything from the IPU. I think both approaches are valid. I'm just saying that in OPI, we cannot probably choose either one. So we need to build something that can accommodate both of them.
Oh, naturally, yeah, I do understand. Especially, I understand where Dell was coming from, especially with the adapters that don't employ their own BMC. So it only makes sense for, if you would like to, let's say, establish a boot order of the IPU, and knowing that or the DPU, sorry, in this case, definitely BMC is taking the role of allowing external client or the user of such deployments, a manager or some administrator to insert, to push that configuration towards the entity, in this case platform BMC, and store that configuration until it's picked up at the next boot of the DPU.
So since you're so knowledgeable and understand this topic, I would encourage you to take the lifecycle MD markdown page and
okay, sure.
And butcher it, add a bunch of pictures and more text, and propose your way to do it. Create a pull request. We can all review it next meeting or the meeting after that. Because what you see on the website is what we as a community created so far. And as you see, the participation is still desired to be.
Okay, I didn't want to come out as cocky or anything. It's just I'm asking questions because well, on our side we also have to solve those. We're already running in circles. I agree.
Anyway. And on Dell side we have to solve it as well. And this is why I proposed is let's solve it instead of signing a bunch of NDAs and solve it proprietary between Dell and Intel. Let's bring it to OPI and solve it across all vendors and across all servers or integration companies. in the open manner.
Mhm.
And we can honestly discuss pros and cons. You probably worked with Lee, if not that you're going
Well,
to.
for long and not only on IPUs.
So we can have an open discussions here, which are not, NDA based. We can have different approaches, and we can try to solve it together as a community. And hopefully, we can come to a better, a more comprehensive resolution and architecture.
Mhm.
I'm
Yeah, well,
very welcoming.
Yeah, it would be very nice to get feedback on some of the ideas, but even if they are completely stupid or anything, just to shatter them down, or I definitely would be very welcome to be proved wrong on many issues, just to have something better.
So the way to do it is a couple of ways. First of all, if you have a concrete proposal and everything, you can create a pull request, and then we can bring it to the meeting. We can all review it. All the comments and everything will be saved in GitHub. Either we merge it eventually or abandon it. Still, we have the documentation order to happen. Another way, if you have very raw ideas that you can just bounce off people, we can always do it either via mailing list. You can write an email to the OPI dev mailing list, when we can all comment and have a live discussion there. Or if this is something that doesn't require thorough documentation, we can do it on Slack. Since we're using free Slack version, the messages are being expired. So if this is something that we can just quickly discuss and then document, we can do it on Slack as well. So there are a couple of ways where we can do it. We can also always bring it online to this weekly meeting. If you have a couple of slides that you can walk through the group, so people can ask questions, comment on what your view is. This is also very much welcome. Just send me an email or a Slack channel that you want to put it on the agenda next week, and definitely come in, present. We will, as a group, review it, give you our comments and stuff.
Okay.
And this topic is kind of tied to the boot sequence topic as well, right?
Oh,
They run
definitely.
into each other.
It's going to be tied to anything, because anything and everything in here, to be honest, because we were talking just for a moment with the gRPC, for example. It makes a lot of sense to even establish, yeah, we have API obviously, but who is going to consume it? What's the main purpose of having that, right? I mean, obviously it's inventory, but who is going to do that? So the just even hashing out the blocks like you have here in the deployment. I used the provisioning things the diagrams for the management or the life cycle. Overall, I think that those pictures are going to apply as an overall diagram of a deployment, not only for a specific purpose, but for all the purposes that we're discussing in API.
And for these pictures, I created those pictures quite a while ago. So if you see something that is missing, you want to add something from Intel perspective, these are all editable PNGs. So you can edit them, propose them as a new version of pull request, and we can all iterate on this. You can, add a bunch of things here. So feel free. This is not set in stone.
Okay.
Yeah,
So what is?
and there can be multiple workflows defined by API too, right? That are sort of, workflow A, B, or C, and they encompass different use cases and different ways people want to do things. We don't have to have a grand unified workflow that covers everybody and everything.
Oh, sure. It just might come out that we can use one for more.
Yeah. And again, this is an area we haven't visited in a while, so would be good to spend some time on it again.
Sure. Okay, so I don't think we ended up with the answer for this particular item on the redfish proxy. So, what is the purpose of it in the picture? I
don't remember from the top of my head, but I took a note to try to remember.
Oh, okay.
To me, it looks like you're extending the redfish server onto the DPU. And that's
I mean, it's yeah. Obviously, you could do it, but it seems like at least if the redfish proxy is sitting on the NIC BMC, it suggests that the hierarchy of the NIC BMC is above the platform.
Like, yeah, but that's not what the text says. If you read
exactly, the text maybe explains some of it.
Yeah, I mean, it's okay. Or enable the Redfish proxy on the NIC BMC, whose role to request commands from platform Redfish server and submit them into local. So it's a pool manner from the platform BMC. So
Yeah.
it's the other way around.
The NIC BMC is a slave to the host BMC.
Well,
That's
to
pretty
be clearly honest, it's at minimum inherently due to the fact that it's a PCI card most of the time at minimum. It's because of that it's a slave only on the level of thermals and the power, let's say. But aside from that, it doesn't nothing stands nothing stands, let's say, in challenging. It's not challenging to have it the other way around easily, right?
No, but
Especially
I wouldn't say only thermals
Mhm.
and power. For example, if you have server with NVMe SSDs populated in them, obviously this information is on platform BMC. So let's say we want to connect some of them to the IPU, or let IPU use those SSD drives, right? So this information, just from the top of my head, is in addition to thermals and power that we would like to share. So chassis related stuff as well. Storage related stuff as well.
Yeah, and without that text note, you could interpret this the other way, where the NIC BMC is in fact the master of the platform and it's controlling the BMC of the host, right? In a bare
yeah,
metal
I would
interface.
I would see it as the rack like some sort of a top of the rack rack manager, sorry. If the platform is like the regular server platform, it would be like additional. I know conceptually. But
looking into the Git history, looks like Shahar from NVIDIA added this specifically Redfish proxy edition with the text below. And he left NVIDIA since, but maybe I can reach out to him to ask.
All right. Thank you very much.
Thank you. So again, as an action item, if you can take this further, we as a group would very much appreciate it. LifeCycle markdown page, or have a few slides presented. What is your view? How you think this should be solved? We're all very welcome in any contribution. As you can see, we spread it very thinly. We have an inventory, a lot of inventory information. We have a lot of secure zero-touch provisioning going on, and we have this upgrade and boot sequencing. I think anybody that can come and help out with especially with a fresh perspective, since you just joined, we very welcome in that contribution.
Yeah, I could try. The diagrams are in SVG, right? So technically,
we do it with Draw.io. I can post it here. We use this website to generate.
Yes. I'm using it also. So
okay. So
okay.
you can use a PNG and edit. Yeah.
Okay.
Perfect. Okay.
It's all. I think it's also exportable through their own XML like Draw.io format, right?
Yes,
so you
but
could just,
then you wouldn't see it in GitHub. I wanted to save it as editable PNG, so we can save it in GitHub and actually show and browse through the page.
Yes.
But yes, you're right. Okay, so I don't have any more topics. We have 10 more minutes. We can either end the call now, or we can have a free discussion on anything. Like, what do you think? Where you think this is going? What we're lacking? Focus, communication, contribution, participation. I see no NVIDIA today, for example, right? Whether it's indicative of something or not. Team and Prasuni, obviously TSC members, right? So we do expect this to be escalated to TSC, the participation level.
Understood. Yeah.
On Intel side, two of the guys that are normally attending, Sergey and Andrei, had conflict today. So
yeah, Andrei pinged me. That's fine.
Well, I'm looking forward to looking at Ted's stuff on the boot sequence, so I'll have to go look that up.
Cool.
And I think that's a very rich area for us to be working, Boris. So looking forward to that.
I'm
Yeah.
not sure I'd
Yeah.
say you should be looking forward to it, but you're right, it's a rich area.
Yeah, boot sequencing stuff is going to be valid no matter the deployment, to be honest. No, at least not from the 3 pictures, well, 2 pictures, right? No matter if it's if the adapter has a BMC or not, not necessarily.
And there's plenty of other complications as well. So plenty of opportunity for discussion.
Oh, definitely. Looking at how things were being discussed on our side, yeah.
Okay. So I encourage people to work more offline. Not wait to these weekly meetings, because otherwise we'll be progressing too slowly.
And feel free to hit me up on Slack to work offline. Don't, as Boris said, don't wait till next week if you have questions, comments, or pushback.
And on the SM bias validation tool, once Lee Palette has the specs defined, then we can work on that.
Lee, we're waiting for you. We're all ready.
Okay.
Finger on the button. Just fabricate something, generate.
All right. We'll do.
Thank you, everybody.
Thank you, Boris. Thanks.
See you next
Thanks,
week.
Boris. Thanks, everyone.
Thank you. Bye-bye.